Hi everyone, today we are going to make an engine sound system in Metasounds. Let's see how it works. We start it, the engine starter goes off, the engine sound starts, we can change the RPM, and when stop it will smoothly stop. Let's see how it's made. First of all, we need an on-play event. We need to create a stop event. That is a trigger. We need to create an input. We only want to trigger the engine starter once, unless we have stopped it. Let's use a trigger once, and we are going to a wave player. Here we set the engine starter, and we set it to not loop. Then for the engine sound itself, on play we need a trigger delay, as we do not want to start the engine sound as the starter starts to go off. So create a new input. It is a time. My value is 0.4, whatever works best for you. It depends on the sound asset you are using. We need to create a variable down here. I call it pitch out, and this is a float. Also the engine idle sound will go here, and this one is looping. We want to control the loudness depending on the RPM. I grab the pitch out value. You can see what I did. This also depends a lot on the asset you are using, so you will have to play around with these values. Then both of these wave players go into a mono mixer like this and to the output. So before getting to the harder part of the code, let me show you a simplified version of it. Here we need an in RPM input float, and I set it maximum to 10,000, and we want to interpolate and set its value to current RPM. This will make it smoother. For the stop, let's simply just go from stop to unfinished. And to create a pitch output from our current RPM input, we are going to need to set some variables again. Let's create these variables. I'm going through each one of them so you can see its values. The RPM idle is the RPM value the engine is meant to idle on, and the high is its maximum RPM value. Pitch idle is going to be the minimum pitch we use. Let's use 0. Let's try it like that. And the pitch high is the pitch value we are going to use on maximum RPM. So let me show you. This is pitch idle. And the one you could hear at the end was the pitch high that played on maximum RPM. To make everything smoother, we are going to need some changes. For example, we want the interpolation time to change. On play, it's going to be 0.1 as before, but if we stop, then we want to grab the delay stop, that is a time input. It's going to smoothly transition from the current RPM value to 0, or the minimum we set. And here, instead of the RPM going to target, we go through a trigger route. The stop value is going to be 0, and the in RPM is going to be set after we have started the engine. So on play, trigger delay, and the delay time will be the delay start. That's 0.4 for me. Stop just got a bit more complicated. Instead of going straight here, we need a trigger delay, and we are going to use this delay stop time value. Let's go to the RPM. Instead of connecting the idle RPM idle to the in range A, we only want to use it on play and after that. But if we stop the engine, then it has to go down to 0. And same with the out range A. If we start playing, then it's going to use the pitch idle value. So I use this delay here, just like up here. But on stopping or playing, so before the engine actually starts up, I want to set it to -2. -2 will be slower, like this. So again, it depends on the assets you are using. For showing how to use this in blueprints, I made this engine actor. What it does, after a 2 seconds delay, it will start playing, because I have set it to do not play automatically when placed. And after another delay, set the RPM to 4000 from 1000, and after another delay we are going to stop it. If you want to use trigger parameters, just put in their names in an execute trigger parameter node. And to set floats, you need to use this node and set their names here, whatever you use here. So in RPM for me and stop. Let's see how it works. And it works perfectly. I hope this video was helpful for you. If you liked it, you know what to do. Have a good day, bye.